Okay, this is Zeng from Team 3, and this is our system. It's a tiny catapult. Okay, the first part is the introduction of the system. Our system has a base, and has an arm, and has a structure like this. It's very easy, and the strings in between. And the function of the base, there are two functions of the base. The first, it supports the whole system. So the system, without the base, the system won't exist. And the second part is to reduce the uncertainty, because the higher the base is, the system won't moving around. Like if you have a light base, and if you pull the arm and release it, the system will move by the power of the arm. So if you have a heavier base, the system itself won't moving around, so that it won't affect the result you get. So this is the way how we reduce the uncertainty and increase the predictability. And the second way we increase our predictability is to keep the strings, because the power, we don't want the power of the arm to change, because our x value is the height of the arm, so we don't want it to change. So we just use glue. First of all, we just tighten the strings, and we just use glue to fix these two parts, so the strings won't change its rotation circles, so it will be a fixed power of the arm. So this part, it won't affect the results. And the second part is the data we get. So we did linear. Sorry for the bad quality of my paper, and it's linear and cubic and quadratic. I'm not sure if you can see clearly. Okay, first we saw linear. We saw our data modeling doesn't quite fit these points. So compared to the other two data, we just get rid of the linear because it's not very precise. So the second, we compare the quadratic and cubic. But from graph, we can barely see the difference. So we start to compare their S parameter. So the S parameter for cubic is 0.06, and the S parameter for quadratic is 0.16. So compare these two numbers, we can conclude that cubic model is the best because it has smaller S parameter, and meaning suggesting that it's more precise and it's better to fit these points, and it has a better predictability. Okay, this is for data. And the third part is the predictability of our system. So like we did in class, we choose the x value or the height of the arm to be 5 centimeters. So it's about this position, and we release it, and we record the ball. There is a ball here, and the first point the ball hits, the distance from here to the front of the system. So we basically did 3 times, and the first y we got is 14.3, and the second y we get is 12.7, and the third y we get is 15.2, and the average we calculate is 14.067, and the predicted y is 13.6, and after calculation we found the error percentage is 3.43%. And this is the predictability of our system. Since it's a relatively small number, so I think the predictability of our system is not too bad. But there is a lot of improvements we can do to increase the predictability, and this is also our the first part of my presentation. So the first way to increase the predictability is because the base is too weak, it's not very heavy. So we basically use tape. Sorry, I don't have tape, but in class we have tape. We use tape to fix the base to make it like unmovable, so it won't moving around and to affect our result. So this is the first improvement, and the second improvement is caused by the shaking of my hands, because when I'm releasing the arm, I always moving around, so it will change the x value or the height. So we use the improvement we are thinking about is using the strings to make the arm to make sure the arm won't moving around, and when we release the arm, we just cut the string, so it will release from a certain height. So in that way, we reduce the possibility of human errors, because my hands apparently will moving around, so it will change the height and change the x value, which will affect our result. And this is the second improvement. And the third improvement is we can buy, because we locate our first point, the ball hits, using our eyes, so it's not very precise. So I highly recommend we go to buy a platform, and on the surface of the platform there are very tiny small pressure detector. So the detector will get information. If the ball hits, they will send the information to my computer. So in my computer there will be a whole graph, a complete graph of the hits, the first point the ball hits, the second, the third, like so on. So we can precisely know the distance from the front of my system and to the first points the ball hits. So these are 3 improvements you can do to increase our predictability. And this is Zeng from Team 3. Thank you very much for watching.